Okay, this is lesson 3 in chapter 1. We are going to be talking about multiplying and dividing monomials. So we should talk a little bit about the term monomial. Monomial is just a word we use in mathematics to refer to either numbers or variables or a combination of numbers and variables, and that can include the products of those numbers and variables. So for example, 3 would be a monomial. 7a, or 7 times a, is a monomial. Or 4ab, which would be 4 times a times b in mathematics, is a monomial. These are all monomials, and we're going to learn how to divide and multiply. Example number 1, our instructions are to simplify. So in example 1, we have the term 5 squared, the monomial 5 squared times 5. So I want you to learn to think of this as 5 times 5, which is the 5 squared, times 5. And obviously all of you can take a look at this and say that that's 5 times 5 times 5. The exponent for that is obviously going to be 3. But it is going to be a really important step for you to notice that in this case it would be as if there was a 5 to the first power here. We don't write 5 like that customarily, we just leave it as 5, but 5 to the first is 5. So in other words, it's 5 to the 2 plus 1 power. We are adding the exponents. When we multiply two monomials, we add the exponents. If you need to write it out like this in order to understand it and get the problem right, then by all means do it. But you're going to see later on that it starts getting fairly complicated trying to keep track of all these numbers when we start working with larger exponents on our monomials. Example number 2, we have c cubed times c to the 5th. So we have c times c times c to the 3rd power, and then we also have c to the 5th power here. Again, we can start looking at it this way, but we can also start moving to the step where we just recognize this as c to the 3 plus 5, or c to the 8th. Count them up, and we have indeed 8 c's. Okay? Example number 3. They throw one more thing in here. We now have a coefficient of our variable. So we have negative 3x squared times 4x to the 5th. Think of this all strung out as all the different terms. We have negative 3 times x times 4 times x times x times x times x times x, 5 x's. Okay? So now we could regroup these and say that that's like negative 3 times 4 times x, and all these x's here. The quick, easy way to eventually, I want you to get to this point where you can take a look at this and say that this is negative 3 times 4, negative 3 times 4, negative 12. And x to the 2 plus 5, which is x to the 7th, and jump right to it. I'm sure many of you will get to that fairly quick. Please press pause and do letters A through C. Example number 4. 4 to the 8th divided by 4 to the 2nd power. So we could look this out as all 8 of our 4's up here and 2 of the 4's here, and then we can go through and cancel. You've done this many times in mathematics. Those all become 1's. We can ignore them, although we will still have 1 down below. So we have 1, 2, 3, 4, 5, 6, 4 to the 6th power. But now when we're dividing monomials, we can look at it as a subtraction of the exponents. So it's 4 to the 8th minus 2, 4 to the 6th. However, our instructions were to simplify, so don't forget that you cannot answer this. That is not simplified. We have to put 4 to the 6th in a calculator, multiply it out, do whatever you have to, and your answer is 4,096. Example number 5, we have n to the 9th divided by, or over, many people will say, n to the 4th. All of our n's here, our 4 n's here, we can cancel them out, and we end up with n to the 5th. Quick, easy way is n to the 9 minus 4. n to the 9 minus 4 is n to the 5th power. Example number 6. We have 2 to the 5th times 3 to the 5th times 5 squared divided by, or all over, 2 squared times 3 to the 4th times 5. This is a good example about the fact that you want to ultimately get to the red step here where we're just subtracting, or in the case of multiplication, adding exponents rather than writing this all out. But if you still need to write it out, go ahead. 2 to the 5th would be 2 times 2, 5 times. 3 times 3 5 times, and 5 times 2 twice. 2 times 2, 3 to the 4th, and 5. And now we can go through and cancel this out. We can cancel these and these. And we end up with 2 to the 3rd times 3 to the 1st. We're just going to write it as 3 times 5. However, remember, we are still not finished yet. 2 to the 3rd is 8 times 3 times 5. I can do this in my head because I'll go with this first. 8 times 5 is 40 times 3 is my final answer of 120. Now last, the example number 7. They tell us that the Hawaii shoreline is 2 to the 10th miles long, and that the New Hampshire shoreline is 2 to the 7th miles long. And then they ask how many times greater is the Hawaii shoreline than the New Hampshire shoreline. And a lot of people will recognize that or hear that they say times and say that this is a multiplication problem. And they're going to say 2 to the 10th times 2 to the 7th is 2 to the 10 plus 7, or 2 to the 17th. Well, if you put 2 to the 17th in a calculator, you're going to end up with a huge number. And you should recognize immediately that Hawaii shoreline cannot be that huge number times the New Hampshire shoreline. It doesn't make sense. This is indeed a division problem. It's 2 to the 10th divided by 2 to the 7th. Understand that if we have the Hawaii shoreline, let's say represented by this number here, okay, and we'll go with 8, okay, and the New Hampshire shoreline is represented by some smaller number, how would we get from here to here? We would have to divide it into individuals. So this one would be represented by a single circle, okay? So in other words, 2 to the 10th divided by 2 to the 7th is 2 to the 10 minus 7, or 2 to the 3. 2 to the 3rd power 2 cubed. And 2 times 2 times 2 is 8. So Hawaii's shoreline is 8 times greater. And that's a number that makes sense. If you had done it the other way and did 2 to the 17th, put that in a calculator, you should immediately realize that number does not make any sense at all. Please press pause and do letters D through I. Here are your solutions to Lesson 3, Chapter 1, the letter problems. We start out with letter A. The problem is 9 cubed times 9 squared. And remember, we can split it into 9 cubed right here times 9 squared, and we'll end up with 9 to the 5th. But our shortcut is to go 9 to the, in parentheses, 3 plus 2, or 9 to the 5th. And then, of course, remember, you need to simplify that, which is 59,049. I would like you to make sure you get into the habit of putting your commas in on your answers, so that whenever we correct in class, it's easy for a fellow student to take a look at that and quickly determine whether or not the correct number. Letter B is a cubed times a squared. Here is the way we can lay this out step by step. Hopefully by now we don't need to. It's a to the 3 plus 2, or a to the 5th. Letter C. We have negative 2m times negative 8m to the 5th. Notice they put the second one in parentheses, but they didn't need to put the first one in parentheses, because you can see that it's negative 2 times n. This is one of the things that kids sometimes don't understand about this. This is negative 2 times n. Times is implied here, where they will start doing this a lot in algebra, so get used to the fact that they use parentheses like this to express multiplication, as well as the dot. And then that is times negative 8, which is times m to the 5th. This is all multiplication here. So because it is all multiplication, we can use the commutative property of multiplication, and we can put this in any order we want. So in your head, I would like you to start to see this as negative 2 times negative 8, negative 2 times negative 8, times m to the 5th, which is m to the 1 plus 5. And we get, of course, negative 2 times 8 is positive 16. M to the 1st times n to the 5th is m to the 6th. So here's our final answer. And eventually we'll just start looking at this and immediately be able to write this down. You'll see that in a minute. Letter D, we have 5 to the 7th divided by 5 to the 4th. So that is 5 to the 7 minus 4. 7 minus 4 is 3, so it's 5 to the third power, and that is 125. Again, here it is all written out if you need to count them up and make sure that you understand it this way, but your goal is to get to the point that you can do this. Letter E. X to the 10th divided by x to the third, which equals x to the 10 minus 3. 10 minus 3 is 7. Our answer is x to the 7th power. Letter F, we have 12 times w to the 5th over 2 times w. So we can break this into two pieces. 12 over 2 times w to the 5 minus, remember this is an implied 1. Okay? So we have 12 over 2 is 6. W to the 5 minus 1 is w to the 4th. Letter G. Now you can start seeing why we're going to want to get to the point where we can just jump to this method here, or things would get really sloppy if I wrote out all these numbers. 3 to the 4th times 5 to the 2nd times 7 to the 5th, all divided by 3 squared times 5 times 7 cubed. So it's 3 to the 4 minus 2 times 5 to the 2 minus 1 times 7 to the 5 minus 3. 3 to the 4 minus 2 is 3 squared, 5 to the 2 minus 1 is 5, and 7 to the 5 minus 3 is 7 squared. And then of course we can write that as numbers if we want. 3 squared is 9 times 5 times 49, and that would be 45 times 49. You might have to put that in your calculator, but actually if you think about that in terms of 45 times 50, you might see a method to get an easy answer there in your head, and I'll show you in a couple of problems how you can do a lot bigger problems in your head than you think you can. This one, for example. Letter H. 5 to the 6th times 7 to the 4th times 8 to the 3rd, all divided by 5 to the 4th times 7 squared times 8 squared. So that's 5 to the 6 minus 4 times 7 to the 4 minus 2 times 8 to the 3 minus 2. That's 5 to the 2nd power, 7 to the 2nd power times 8. That's 25 times 49 times 8. Well, if you think about it, 25 times 8, well, 4 25s is 100, so 8 25s must be 200. 200 times 49, well, let's just do 200 times 50 in our head, and then we'll just subtract one of those 200s off when we're done. Well, this times this is 10, and there's 1, 2, 3 zeros. 10,000 minus 200 is 9,800. Do problems in your head when you can. This one here, you're probably thinking there's no way I'd ever get that in my head, and you're going to see that when we're done we can actually do that. Negative 2 to the 5 minus 2, 3 to the 4 minus 1, 5 to the 7 minus 4. Should see what we've got there. Negative 2 to the 3rd power, 3 to the 3rd power, 5 to the 3rd power. Negative 2 times negative 2 times negative 2 is 8, but negative times negative is positive, times one more negative turns into negative again. So we have negative 8. 3 times 3 times 3 is 9 times 3, 27. 5 times 5 is 25, times 5 is 125. Now again, we have 8 times 125. We're going to skip the negative, we'll write negative right away. So we have 8 times 100 is 800. 8 times 25 is 2 more 100. That's 1,000 times 27, 27,000. Negative 27,000 is your final answer. Please do guided practice.